Let's try another one, E and F. Minus 2 columns and minus 4 columns. Where will they move from? Will they move from E to F or from F to E? Will they move from E to F? I see answers are rolling in as fast as possible. Okay, everybody seems to get this right. Okay, lovely. F to E. Thank you very much. F to E. F to E. Okay, I want to introduce you to a new concept now. We did this in grade 10, and I don't know if you remember. The law of conservation of charges. The law of conservation of charges. Guys, I do not leave any details out. The law of conservation of charges. I'm not going to leave any details out. The law of conservation of charges. And what does this law state? It's a grade 10 law, all right? In physics, we always state in an isolated system, all right? In an isolated system, the net charge in an isolated system. No, not that one. Not that one. In an isolated system, the net charge remains constant in any physical contact. The net charge remains constant in any physical contact. In an isolated system, the net charge remains constant in any physical contact. It means the net charge remains the same in any physical contact. The total amount of charge in a closed system remains constant. Good. But you need to add in any physical contact. That clause is very important. In any physical contact. Alright? I'm going to add a little note there again. In any physical contact. Okay. So in an isolated system, that remains constant. I'm just going to add another note here. When charges are brought in contact, all right? When charges are brought in contact, and separated, charges move. I'm repeating that for the third time because it's important. From where they are more to where they are less. Such that the two objects will now have equal charges to maintain a constant net charge. When charges are brought together in contact, all right, and separated, charges move from where they are more to where they are less, such that the two objects now have equal charges. Charges move from where they are more to where they are less, such that the two objects now have what? Equal charges to maintain a constant net charge. Very important information. We're going to do a small calculation there quickly. I hope we're okay with the notes. The new charges on both objects can be calculated by adding the old charges together, by adding their magnitude rather. No, by adding the old charges together and dividing by 2 and dividing by 2. We then say Q new will be equal to Q1 plus Q2 over 2. Q new will be equal to Q1 plus Q2 over 2. Let's quickly run through. Okay, we are going to be logged out now any second from now. You know what to do, right? We just log back in. Let me quickly do an example, but we will be kicked out just now. Example. Q1, let's have positive 5 columns. And Q2, let's have negative 2 columns. Guys, what is my net charge here? It will simply be Q1 plus Q2. Wait. Hello? Okay, can we then continue here? Can we continue? All right. Now, we said, what are we going to have? What's our net charge? Remember, we said this is positive 5, right? So what's going to be the net charge? Can you guys calculate for me quickly? Please calculate. You guys are wrong. You guys are wrong. Okay, Lindo quickly fixed it. Lindo fixed it. Smart enough to fix it. We have positive 5 plus negative 2. No, guys, I'm looking for Q net first. I'm looking for net charge first. What's my net charge? 5 minus 2 would give me positive 3 columns. This is the net charge. I have my reason for calculating the net charge first. The net charge is positive 3 columns. All right? Positive 3 columns. Are we okay with the net? First, the net charge. Now I can go ahead and say the new charge. The new charge on Q1 and Q2. The new charge on Q1 and Q2. Remember, now it's going to be Q1, Q2 divided by 2, right? Just a second. Now we can then divide by what? By 2. Okay, so the new charge on Q1 and Q2 will be Q new Q1 plus Q2, and we already have that, so we are saying it will be what? Positive 1,5 columns. I hope it makes sense so far. I hope it makes sense. I want us to check something. So we are now saying on Q1 new is positive 1,5. Q2 new is also positive 1,5 columns. What is my net charge here? My net charge is the addition of the 2, and that gives me what? Positive what? 3 columns. Two things that we have done. Do you see that my positive 3 remains the same? That is the law of conservation. It states that what? The net charge should remain what? The same. The net charge remains the same. I hope we're okay with this. I hope we're okay. Please let me know. Just say okay, okay, okay. You know how we do it? We type okay if you're okay before we move on. We're about to move on, but just say okay, okay, okay if you're okay. Quickly, everyone. Lindo, type your question in. You said you are confused. The net charge, net means total. The net before we brought them together and the net after we have separated them should remain the same. The net before we brought them together was three columns. Alright? And the net after we separated them, 3 columns. Keywords, isolated system, no external. Lindo, are you okay? A quick summary. Oh, you understand. Alright, for every other person, before we brought them together, Q1 was 5, Q2 was negative 2. But the net charge in the system is positive 3. When we brought them together and separated them back to their distances or to their original position, they now share charge such that they now both have 1.5 and 1.5 equilibrium. But the net charge still remains what? The same. How do you calculate the net after? Just add. Remember, net means total. Alright? Net means total. The same thing we did here. We added the first and the second. 5 plus negative 2 to give us positive 3. Add these two. 1,5 plus 1,5. It will also give you 3. Are we okay? Somebody was asking that question. Are we okay? Are you okay with my answer before I move on? Let me know. I don't want to lose anyone on any slide. Lovely. So we can then go on to the next slides. Good. Let's go on to the next slide. It's going to be, we still have an hour, so we'll cover what I want us to cover today. Let's go on to the next slide. Property number 3. Charges can be quantified. Charges can be quantified. And this is what we mean by quantization. Keyword. Quantization. And this is basically talking about quantity. Quantity. How many electrons? Yes, only negative charges will be transferred. Stabile? Only negative charges will be transferred. Only negative charges will be transferred. Charges can be quantified. Quantization. And here we are talking about the number of electrons. We are now talking in this case about the number of electrons. So if I tell you the quantity of charge is positive 2 columns. How many electrons are here? That's what we talk about. Charges can be quantified, which is quantization. How many electrons? You see, now we want to count how many electrons. I'm going to take you back to your formula page. All right, I need you to see this formula. Take you back to your formula page. There we go. How do we deal with quantization? How do we deal with quantization? So if you check your formula page, there is a section called electrostatics, and that's where I am going to be working from tonight. This formula is used for quantization. Here, N equals to Q over E. So please take note, N equals to Q over E. It's the same with this one, all right? It's just different representations. N equals to Q over E. Let's go write it down. N equals to Q over E. N is the number of electrons. Q is the quantity of charge. And E is the charge on an electron. Okay, Yogama, you seem to be done and way ahead of us. We will work it out together. We would work it out together. And what I want to work out, guys, quickly would be something here. All right, so here we can calculate by saying Q over E, and we know our E already, right? 1,6 times 10 to the power that. Let me quickly explain something to you. Oh, beautiful stuff. Beautiful stuff here. Beautiful stuff here. Guys, I need you to follow me here. I'm going to use this first, and I'm going to go back to that example we did. You see this charge here? We're saying Q is 2 columns, positive 2 columns. Hold on. Positive 2 columns. Watch this. Q is positive 2 columns. I want to ask you a question. From a neutral point, from a neutral charge, let's say Q was first neutral, which means Q was first at 0. Do you think we lost electrons or gained electrons to get to positive 2? From 0, no charge, to positive 2. Did we lose electron or did we gain electrons to get to positive 2? From neutral to positive 2, was it a loss or was it a gain? Loss. Okay. Loss or gain? Loss or gain? All right, everybody's telling me loss. Can we prove that we lost? How many electrons did we lose if we were to lose? And how many electrons did we gain if we were to gain? We did not lose 2. That's where I want to go. We didn't lose 2. The quantity of charge is positive 2 columns, but how many electrons make up that positive 2? No, Yongama. No. Listen, how many electrons did we lose or gain? N equals to Q over E. Let's check. This one is 2 over. What is the charge on an electron? Negative 1,6 times 10 to the power negative 19. And obviously, your answer would be a negative. My calculator, I'm sure you do have your own calculators too. Alright, 2 divided by negative 1,6 times 10 to the power negative 19. Negative 1,25 times 10 to the power 19. Negative 1,25 times 10 to the power negative 19 electrons. We lost. Can you see this negative? This negative is telling us that we lost. I hope it's making sense. We lost because of this negative. Please tell me you're okay, or if you're not okay, let me know. Let me know if we are okay or we are not okay. Right. Please make sure you respond. Make sure you respond. All right. Everyone seems to be okay. Let's take this calculation a bit further. Let's take the calculation a bit further. When it is negative, that means you lost. So do you say lost when positive is gained? It depends on the number. We can also gain electrons and it will still be positive. All right. Let me see the full name. Pumudzo. We can also gain and it will still be positive. It depends on what is gained. Please do not write on my board. Please do not write on my board. Okay, if we all start writing on the board, it's going to look messy. All right, Pumeti, I'm sure we'll find an example that will answer this question along the way, but it doesn't mean that it will be positive and then lost. No, if it doesn't get enough, it will still remain as positive. Okay, all right, let's look at this.